Good morning, everyone. Yes, we just started logarithms last time, and the logarithm was created, so to speak, okay, created to be an inverse of exponential function. All right, so this is what we did over here. Y equals a to the x. As you write this one, this was an exponential function, and we have to be careful that a cannot be any value over here. Well, as most values are okay, but we are going to exclude a equals 0. A equals 0 and negatives, and we exclude a equals 1. It may come in as like a surprising thing, okay? But we do not include a equals 1. The next one is y equals log of x to base a. Again, because this a comes from this a base in the exponential form, therefore we must apply the same a values. Okay, so there are two categories over here. So do they make any difference? So for example, a equals 1/2 and the a equals 2. They belong to two different categories, and do they make any difference? Yes, they make a big difference. Either way, for both cases over here, this means that those functions are decreasing, and when you have the base greater than 1, in these cases the functions are increasing. That is a big difference. And only for the same a value, so for example a equals 3 in this case, okay, 3 to the f of x equals 3 to the x, then its inverse function is log of x. Oh, here, same thing. Same a value. Therefore, you must have the base 3. Okay. Another thing you must remember is, because we are going to apply this one, so for example, when you solve the equation and x or y, some x value turns out to be like x equals negative 10. Are we going to accept it as a solution or not? Okay, depending on this domain and range stuff. So, domain of this exponential function is set of all real numbers. So from negative infinity to positive infinity, and the range is positive real numbers. So when you switch to its inverse, what's going to happen? Yes. When we found the inverse function, we switched x and y variable, correct? Therefore, x, the collection of all x values, that is a domain. So domain of this will go to range. Therefore, negative infinity to positive infinity over here, and this range comes as a domain. So that is from 0 to infinity. In other words, over here, when you have an exponential function, the range, the y value you are going to get, or any function value you calculate, that one has to be a positive real number. It cannot be 0, it cannot be negative, only positive real numbers. On the other hand, when it comes to logarithmic function, this time domain is positive real numbers. Therefore, you cannot put log, for example, negative 2 to base 3. You cannot do that. Okay? So, for example, yes, pick up your calculator. You will need a calculator for today's class. So, for example, pick up log key. Log, okay? And then enter negative 2. What's going to happen? It's going to say error. Or if it's a good calculator, it's going to say domain error. So what did we do wrong? Well, that means domain is only positive real numbers, but we entered negative 2. That's what the calculator is saying. All right? So these things are very important. And another 2 minutes for the meaning of logarithm and the conversion. Okay. So let's say you have comfortable numbers, 5 squared equals 25. Everybody knows that. Now we are going to convert this one to logarithmic form. So what do? When you convert to logarithmic form, first, of course, we need log. And then go over here. What is a base? Base is 5 and keep the same base. Okay? Base is kind of an anchor for our conversion. And then what do? 5 and 2 on the same side, and then 25 was on the opposite side. Now bring 25 into the same side. And then this 2 goes the other side. So as a result, this equivalent to this is, in logarithmic form, is this. So how do we understand? It is this. Well, 25 is what power of 5 is that? Or what power of 5 will make 25? Everybody understands that 5 squared equals 25, therefore answer is 2. So in order to calculate logarithm in your head, well, you must know those all exponentials. Okay? So convenient ones, like, well, 2 to the third, 8, 2 to the fourth, 16, 2 to the fifth, 32, 2 to the sixth, 64. Okay, 2 to the 10th is an interesting one, 1024. And 3 to the third, 27. 3 to the fourth, 81. 3 to the fifth is 243. Up to this much, if you know, okay, if you remember, and just make it usable anytime you need to. And the 4 cubed is 64. 4 to the fourth, therefore when you multiply this one by 4, so 256. Okay, so 4 to the fifth, yes, that is 4 times this. This is 1024, like that. Okay, so now conversion between logarithm and the exponential. So let's make it like this. Log, you have a and c equals t. So I make ACT, or you may see ACAT over here. So let's convert this one to exponential form. Well, exponential form always start with the base. Base is a. Yes, this is the anchor. Make the base, and then c and t change the size. So left and right. So t goes over here, and c is this. Okay, so now just once you have the same base, you are going to switch these two. That one is, I think, the easiest way to remember, and you can practice many times. And yes, you are going to be very comfortable with that, this conversion. All right? So today, properties of log. Well, what kind of properties of logarithm have? So here we go. Here, for x is positive, again y is positive, and a is greater than 0, but a is not 1. Okay, a is not equal to 1. And the first property I'm going to refer to this one as number 1 property is product property. That is this. When you have a logarithm xy to base a, see, product means multiplication, is that right? So you see multiplication in this argument. Again, this is base, and we call this argument. When you have a product in argument, what are we going to do? We can split this one into 2 separate logarithms, but of course having the same base a. So here, log x to base a plus log y to base a. Okay? So when you have a multiplication in argument, you can split into two separate logarithms. So note, what about then log? You have x plus y to base a. It looks pretty reasonable to say that this is plus like this. Well, is it the same thing? So we can separate them and make two logarithms over here. Can you do that? No. Okay? Only when you see product, multiplication, you can do so. Okay. The next one is quotient product. Property, I'm sorry. Here. Quotient property. What do you mean by quotient? So that means division. So this time, instead of x times y, you see x over y to base a. So that means it can be applied to any base. Okay? Base 2, base 10, base 1.2, or base 0.8. Okay. In this case, what do we do? Multiplication, addition. Yeah. Now, division is going to be subtraction over here. Log y to base a. Okay. So when you have this number one property, product property, this quotient property comes pretty naturally. The next one is a very interesting thing. We say this is a power property. So that means you have log of x to the r power. This power r can be any real number. Okay? Any real number, positive or negative, okay? Doesn't matter. When you have this, what can you do about this power r? Well, we are going to push this one to the front. So make it r times log x to base a. Okay? So, power this. So let's look at this way. When you have log a x squared, for example, we can use this power property. Oh, x squared, here is r equals 2. Doesn't matter, any power you can push to the front, so 2 times log x to the a. Yes, you can do so. On the other hand, I'm going to look at this x squared as, well, x times x. Can you do that? Yes, we can do it without parentheses also. However, I feel better when you have a parenthesis. Yes, this whole thing is the argument. Okay. So when you have an x times x, what are you going to do? Yes, you can add the log x to base a plus another log, same thing, x to base a. Therefore, what can you say? You have the same thing 2 times, so 2 times log x to base a. We get the same result. But what do you see? This power rule is very fast. Okay? Power rule is very fast and just easier to use. All right. Next one is a logarithm of 1. So log 1 to any base a. It is asking what? Let's go back to the very fundamental of this logarithm. The definition says, what power of a will make 1? What power of a will make 1? Well, everybody knows that a to the 0 power equals 1, so the answer is 0. So what it says over here is that regardless of base a, if the argument is 1, answer is 0. Okay? So log, so 1 to base 3, log 1 to base 10, log 1 to base 1/2, log 1 to, so let's say, yes, we can use the number e did we learn this e to the x? Okay, so this number e. Anything you have, okay, the answer is going to be 0. And base a logarithm of a. So in other words, when you have this a to base a, this argument and the base, they are equal. So in that case, again, always when you are confused, go back to the very definition. Okay? So this is asking you what power of a will make a? Of course, power 1. Okay? So this is 1. So this time, when you have log 5 to base 5, or log 0.6 to 0.6, or log any number, base e to base e, the answer is going to be 1. Okay? So two different things. This one, the argument is 1, then regardless of the base, the answer is 0. For this one, again, regardless of the base, but the argument is the matching number. They are identical. In that case, the answer is 1. Okay? All right. We are going to apply these properties. Okay, so example 1. I'm going to write on here. So, log xy equals log x plus log y. It looks a little strange because I did not put any base to it, right? Okay, so base is missing. That means base is omitted on purpose. Why? Because base is 10. Base 10 is just omitted. And is it okay? Yes, it is okay, and it is a conventional thing. Okay, because all the days, this base 10 was the most common thing, most common base. That's why we call it common log. Common log. When it comes to like 1 times x, we do not write 1, just x. Okay, this is kind of the same kind of concept. That so 10 is kind of a default one, so we omit that. Okay. The second one was log x over y is what? Log x minus log y. Okay. The third one was log x to the r power. In that case, that power will come into front. So make it as like a coefficient. Alright, so these things you are going to remember and you are going to apply. The many times the problem is that you do not recognize that you can apply these things. Alright, so just whenever you see multiplication, you apply. Whenever you see division in the argument, you apply that, and the power as well. So example 1 over here, rewrite each expression. Assume all variables represent positive real numbers with a unequal to 1 and b as well. So here a log a times 6 to base 7. So how can you rewrite? Yeah. All that matters is 8 times 6. You see, instead of thinking about 48, it's not the point over here. It's not testing your times table. 8 times 6, there is a product. That means we can split into 2 logarithms. So 8 to base 7 plus log 6 to base 7. Okay. The next one is B. Log 12 over 5 to base 6. Again, 12 over 5 is 2.4. We are not asking you, okay, to compute that. instead you look at this one as, oh, this is a quotient, so we can separate that. So log 12 to base 6, division, so subtract log 5 to base 6. Okay. Part C is log cube root of 9 to base 2. And you pause over here. Wait a minute. So far we didn't see any radicals over here, whether that is a square root or a cube root, fourth root, we never saw any radical over here. So what kind of property is the one that we are going to use? Well, think about it. What is cube root of 9? Can you rewrite this one? Yes, we can write this one as 9 to the 1/3 power, correct? So we are going to write this one as a log 9 to the 1/3 power to base 2. So now we have a power 1/3. So what's going to happen? Yes, we are going to push this one to the front. So 1/3 times log 9 to base 2. Okay? Yes, part D is a kind of monstrous one, so I'm going to do it in step by step, okay? So in the margin somewhere, yes, you do not need much of margin in the bottom. So I want you to use it somewhere, meaning I'm going to do warm-up problems first. No radical. Simply I'm going to have log, here base is a, r cubed s squared over t to the 4th. Okay? No radicals whatsoever. So when you have this, wow, it looks complicated, but let's just separate these issues over here. It has a power, s has a power, t has a power. But think about power later on. What's more, just the most fundamental thing over here is that these are multiplied and this t to the 4th is divided. Okay? So something is multiplied, therefore you can say log r cubed to base a plus, because this is a multiplication, log s squared to base a. Now go to denominator. So when you go to denominator, that means it's divided. Okay? So we are going to apply this. So subtract log t to the 4th to base a. You know what I mean? So we just ignored these powers, right, just for now, and then make it this is a times, so you make it addition and this. So we can combine this property 1 and the property 2 together. We can do so. Now it's time to take care of these powers. Each one, r has a power, s has a power, t has a power. So each one has, this one has a power 3. So power 3 goes to the front. So 3 times log r to base a. Here power 2. So 2 goes in front. So log of s to base a. Now subtract